So hello everyone. Today our topic is integration by parts rule, and we will have a look in solving definite integrals at the last part. So here, firstly, our Lausi talked about previous homework. So we have already discussed about our previous homework, right? So we have recording. So we can just skip this part, this one, and this one. So these four are our previous homework. So we have already discussed about this in our previous lecture. So now we are going to talk about integration by parts rule. Okay. So for example, we have a integration here, integration of ln x dx. So we cannot use substitution rule here. Okay. So the integration by parts rule, it came from the dot. It came from u dot v. You already know the derivative of two function u dot v. So their derivatives are u derivative b plus ub derivative. So this was our differentiation formula or derivative formula. So now if we just multiply integration sign on both sides, you see here. So then we get integration of ub derivative dx. So when we take integration, we must take dx. Okay, so integration and dx, these two are all together. So we just multiply integration on the both side. So integration of uv derivative dx, and also we have to multiply integration on the right side. So it will be integration of u derivative b dx plus integration of uv derivative dx. And now we need to calculate the value. So we know that integration and differentiation, they are two different, they are opposite to each other, right? So we can just cancel this derivative and integral sign. Thickness, okay. So you can just cancel this derivative and integral sign, okay? This is the derivative, and this part and this part. These two parts are together integration, okay? So if we cancel this, we can get uv. And here we have integration of u derivative b dx. So we keep v here. Here is our v. And we take this u derivative dx closer. Okay. And then also again, this b derivative dx, it's also closer. Okay. Now if you want to find this value, so we know that there is a small formula I already talked about before. dy is equal to y derivative dx. Okay, dy is equal to y derivative dx. So here we have v derivative dx. So we can write down dv, right? Because from this formula. So I get integration of, and also from u derivative dx, we can write down du. Okay, from this formula. So it will make integration of v du plus integration of u dv. Guys, got it?
Yes.
Yeah. So how about Julian and Lucy?
Yes.
Okay. So this is the integration by. Okay, so this is the integration by part rule. Okay, so we will have. So if we just rearrange this thing, if we just rearrange this last part, so we will get ub is equal to integration of udv plus integration of v du. So if we rearrange this part, we can get integration of udv is equal to ub minus integration of v du. Okay, just take this part on the left side, only this part. So this is the formula for integration by parts rule. This is the formula for integration by parts. Okay. So now we can have a look another example. So here we have ln x dx, integration of ln x dx. So we have some kind of scaling principle for u. Okay. So the order is this. Firstly, we will take we will let u when the function is when the function is arc sin x. Okay, that means for example here we have ln x and we have dx. So you see here the priority. Okay, so this one have the highest priority to become u, and then this one, then this one, then this one. Okay, so like this way we can see the priority list. So firstly we have arc sin x, that means inverse. It can be also arc cos x, arc tan x. Okay, that means inverse trigonometric function. Then we have logarithm log function, so it is ln x. Then we have power function, exponent function, and lastly we have trigonometric function. So this is first one is inverse trigonometric function, and the last one is only trigonometric function. Okay, so here we have ln x, that means we have a logarithmic function, and we have dx, or we can just say x. So x is a power function, so the priority is log function, right? So priority is log function. So we will let this ln x is equal to u. You see here, ln x is equal to u, and this x we let it is equal to v. So we get something like u dot v. Now we can apply our integration by part rule. Okay, so this is the rule. uv is equal to integration of u dv plus integration of v du. Okay, so if this is u and this is v, what is our example? Yeah, so here is our ln x u, and dx, this x is equal to v. Okay, so from the formula we know that uv is equal to, so this is like u dv. This is like this one. Okay, this is like this line, integration of u dv. This is equal to uv minus integration of v du. So we can just write down this way, u dot v. So u is ln x and v is x. So u dot v minus integration of v du, right? So v is x. So x and du, here is d, and u is ln x. So this is u. Okay. So from this formula, integration by part, formula of integration by part rule. So we just we can write down this line. Guys, got it?
Yes, Omar.
Okay. So now we can take this on the left side. So x ln x minus, you see here d ln x. So we know that from our small formula, that is here, dy is equal to y derivative dx. So if I apply that formula here, so this is dy, this is d ln x. So d ln x is equal to ln x derivative dx, right? So ln x derivative is equal to 1 by x, and here is our dx. So d ln x equal will be 1 by x dx from this formula. Okay. Now you can just cancel x, so you get integration of on dx. So integration of on dx is x, right? You know the formula, integration of k dx is equal to kx, right? Kx plus c. Guys, do you remember the formula? Here
Yes, yes.
k is a constant. Okay. So integration of on dx will be x ln x minus x plus c. So integration of on dx will be on minus x plus c. So in total we get x ln x minus x plus c. Okay. Lucy, have any question? Do you have any question? Or Julian?
Can you, yeah, there were you. Please, can you explain again?
Oh yeah, of course, yeah. So you all have to talk like I'm not a teacher, so you can question me anytime. So it is integration of ln x dx, right? So we know that we cannot use substitution rule here, okay? Because if we use substitution rule, it will become maybe very long. So here we have to let u and v. Okay, we have to let u and v. So this is the this is the selecting principle for u. This is the selecting principle for u. So we see here firstly we have to select firstly we have to see if there is any inverse trigonometric function. Okay, then we have to look at log function, then power function, then exponent function, and lastly trig function or trigonometric function. So here in this example, what is that? Yeah, here in this example, we have integration of ln x dx. So this ln x, this is a log function, right? So we let ln x is equal u, and then we have x here, right? So we let this x is equal v. Okay, guys. So we get u and v. So now we can apply our integration by part rule. So the formula is, here is the formula. Integration of u dv is equal to u multiply v minus integration of v into du. So you see here we have some kind of integration of u dv here, right? Because ln x is equal u, because ln x is equal u and x equal v, right? So this is something like u dv, okay? Integration of u dv. So this will be u multiply v minus integration of v du. So u multiply v minus integration of v, that means x, v du. Okay. So we know that d ln x, it will be ln x derivative dx from this formula. Okay. dy is equal to y derivative dx. So d ln x will be ln x derivative dx, right? So ln x derivative is on by x. Guys, do you remember? Ln x.
Yes, yes.
So on by x dx. Now we can cancel this x and we get integration of on dx. So we know the formula of integration of any constant number dx or integration of k dx. It will be kx plus c, right? So
Right.
integration of on dx is equal x plus c. So finally we get x ln x minus x plus c. This is the answer. Julian, you got it? And also Lucy?
Yeah, I
Okay,
got
okay.
it.
So now let's move on to the next question. We have integration of x ln x dx. Okay, so we have integration of x ln x dx. Okay, that means we have a extra x here. So we need to choose only on function as u. Okay, guys. So this is the selecting principle. I already have talked about this. 1, 2, 3, 4, 5. So we have integration of x ln x dx, right? So now we have to think here. Like here we have a log function, and this is our expo function. This is our power function, right? So x we can write down like x to the power 1. So x is also a power function. So we have power function, then we have log function, and also here a power function. So we have to firstly consider log function, right? From the selecting principle for u. Firstly, we have to consider log function. So our ln x will be u. Okay, ln x will be u, and dx. So if I break down this dx, so it looks like dy, right? So dy, it will be y derivative, x derivative, dx. Okay, x squared by 2 ln x is x squared by 2 minus integration of it was x dx. Okay, so do you have any formula for x dx? D ln x. Guys, do you have any idea about this line? Like how do we get x squared by 2 here? Integration of ln x and x dx.
It's x ln x dx, right?
Yeah, so how do we get from x dx to dx squared by 2?
Ln dx, ln x. I don't know how you get this formula. Ln x
I knew
dx.
this, but I forgot. So here the thing is, we have integration of x ln x dx. So now we just let ln x is equal u, because from this order here, selecting principle for u. So we know that we have to let firstly inverse trigonometric function, then log function. So we have log function here. So ln x is equal u, and then we have x dx. Okay, x dx, and here is the sign, integral sign. So integration of x dx. So if I calculate here integration of x dx, So from the formula, it will be x square by 2, okay? Lucy and Julian, do you remember?
I don't remember. I don't know about Julia.
Okay, so there was a formula that is, okay, let me show.
It's the opposite of a derivative formula. You just
Yeah.
have to add one
Yes,
instead of deducting one.
So see here, integration of x to the power n dx. So the formula is x to the power n plus 1 by n plus 1. That means you increase the power of x by 1, okay? You just add on in the power, and then you divide by the power. So this is integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1 plus c, okay?
Okay.
So that means here we have integration of x dx. So we have to increase the power. So here the power is 1. So we increase the power by that means we just multiply, we just add on here, okay? So on plus 1, that is 2, and we divide by the power. So this is x square by 2. Okay, guys. So that's why we write down here x square by 2, dx square by 2. Okay.
Okay.
Yeah. And if I want to just x dx, x square by 2. Okay. And the second line, so it makes a formula. This is our integration by parts formula. So you see here, this is u, right? Because we already let ln x is equal u. So u dv. So we can just let all this part as v, okay? We can let all this part as v. So we get integration of u dv. So from the formula, integration of u dv, see here, integration of u dv is equal to, we just multiply those two and minus integration of v du, okay? Integration of u dv is equal u multiply v minus integration of v multiply du. So this is our u multiply v and minus integration of this is v and du, okay? This is u. Guys, do you understand the second line?
Yes,
okay. So now we can take this on the left side. So we get x square by 2 ln x, and d ln x we already know from this formula, like d ln x, it will be ln x derivative dx, right? Remember the small formula? Okay, so from this formula, dy is equal to y derivative dx. We can write down like d ln x equal ln x derivative dx. That means on by x dx. So this part d ln x dx, I write down here on by x dx, and you can cancel on x from here. So you get integration of x dx, right? And you can just take this constant out. So we have here on by 2, right? So we take this constant out. So finally we get minus on by 2 integration of x dx. And we know this formula. Integration of x dx, this is equal, we increase the power of x by 1 and we divide by the power, right? Remember this formula? Integration of x to the power n dx. Okay.
Yes,
So
yes.
finally we get this 2 and this 2, it will make 4. This 2 and this 2, it will make 4. So x square by 2 ln x minus 1 by 4 x square plus 6. Okay. So we have Topu here. Hello Topu, how are you?
Yes, bro. Problem,
Yeah.
but I
We
only
were
possible
waiting for this group study,
Okay.
right? From
Okay.
like 2 or 3 days ago.
Yeah.
So yesterday I was facing some internet issue. Lucy, do you understand?
It's not a matter. You can continue, bro.
Yeah. Lucy,
Yes.
Julian.
Yes, I
Okay.
do, but the question.
But any problem in some line?
Can you repeat from the second line?
Yes, I can. Yes, I can. So we have integration of x ln x dx. So now we have to apply our integration by part formula. So now here is some selecting principle for u. We have inverse trigonometric function, that is arc sin x, arc cos x. Okay. Then we have log function, power function, exponent function, and trigonometric function. So the priority is firstly this one. Okay. Then this one. And then this one. Then this one. And lastly this one. So here we have ln x, right? And we have x. So x means x to the power 1. So x to the power 1 is a power function, right? And ln x, this is a log function. So we have to let ln x equal u, okay? Because our priority is this way. So we just let here ln x is equal u. So now we have to find our v, okay? And from the formula, our integration by part formula is here. Integration of u dv is equal to u multiply v minus integration of v du. So we will use this formula several times. Okay. So you see the position of v. The position of v is after d, right? That means dv. So we have to convert this function like x. So we already let ln x is equal to u. So we have now x and dx. Okay. So we have to convert this x dx. We have to convert this x dx to something like du. Okay. We have to convert this x dx to something like du. So what will be the procedure? So we have to just make integration. Okay. If we make integration, it will make du. Sorry, dv. Okay, dv. Okay. So we have to make x dx as a dv. So to make this, we need to integration. We need to find the integral. We need to find the integral of x dx. So from the formula, we know that integration of x dx, it will be, we just increase the power of x by 1. So here it was 1. So 1 plus 1, that is 2. Okay. X square by, then we divide by the power. So we get x square by 2. So we write down here x square by 2. Okay. And before that, here is d. So we get something like dv, right? This is d and this is v. Okay. So now we can compare it with our formula. Okay, guys. Do you understand?
Yes, yes.
Okay.
Yeah, I understand, but I can understand the calculation of second line.
Okay. So now here is integration of u dv, right? This is u and this is v. So integration of u dv. So from the formula, we know that it will be u multiply v minus integration of v du. Okay, so we write down here u multiply v minus integration of v and du. Okay, so now if you find this and if you calculate this part, d ln x, so we know a small formula, that is dy is equal to y derivative dx. So d ln x will be ln x derivative dx, right, from this formula. So we know that ln x derivative, that is on by x. It is also from the formula, okay, derivative formula. So on by x dx. So if you put the result here, so it will be integration of x square by 2 on by x dx. Okay, so this part is the value of d ln